This is 10.1 and 10.2 combined together. Both of these sections deal with domain and range of various functions. So as a reminder, we've been talking about functions and domain and range throughout the entire course. And so just as a reminder, here's the definitions again. A function is a relationship between two variables. Again, such that each value of the first variable is paired with exactly one value of the second variable. If you remember, I mentioned to you guys multiple times about the function box. My elementary teacher talked to me. You put a number into it, so you put one value into the function box, and then one value comes out. So, if the function happened to be like x squared, so if I put 4 into the function box, then 16 comes out. So that's what it's talking about. So one variable, and this would be the point for 16. So you put, this is your input, and then your output. And again, we talked about the domain is the set of x values. So this would also be your domain, and this would be your range. So any numbers that you put in there, you might put 7.3 in there. You might put 9.701 in there. Whatever numbers you put in there is your domain. So it's an infinite amount of numbers you could put into the domain usually, and then of course the output as well. So again, the range is the set of the values of the output or of the y. All right. So again, we talked about this. You have to recognize that this is a function. Again, for each value x, there's only one value of y. So when I put 1 in, one value comes out. When I put 1 in, one value comes out, and all the way down. So this is a function. Look at this one. We have a set of domain and set of range. When I put 3 in, then out comes a 7. When I put 3 in, out comes an 8. That's impossible. So when you put a number in, then only one value comes out. So this is not a function. To be able to do that. Then again, you recognize what is a function. Is this a function? If I just give you a set of points, and if you look at this, notice when I put 5 in, then out comes an 8. But here it says when I put a 5 in, then out comes a 9. So no, this is not a function. And then it says state the domain. Again, you can have a domain and a range of a function, or it doesn't even have to be a function. It's just a set. It's just a relationship between the x values and the y values. So you can still have a domain and a range. So the set of domain is the set of all the x's. So you have 5, 6, 3, 4, and 12. Again, you don't need to repeat the 5 again. So basically, again, I look at all my x's, and that's my set of domain. And likewise, if you look at the set of y's, you have 8, 7, -1, 2, 9, and -2. So that's the range that's displayed here. So there's also, if you remember, we did a vertical line test to determine if it is a function. So if you draw a straight line and it hits in 2 spots or 3 spots or 4 spots, then it's not a function. So you can, whatever the function is, I mean, there's an infinite amount of functions, okay? And so whatever the function we look at, you can always do a vertical line test. So here you can see the green dot. So if we draw a line here, notice it only crosses at 1 spot. If we draw a line here, it only crosses at 1 spot. If we draw a line here, it only crosses at 1 spot. And you can draw an infinite amount of lines just to check it and to see if it is. So it only crosses at 1 spot. So yes, this is a function. This is not a function. So you can always do the vertical line test to see if it's a function. And again, the reason why that works. So if this was the point, let's say 3, this point right here, 3.3 and 1.8. Well, this is also 3 and -1.8. So notice when I put 3 in, I got positive 1.8, but when I put 3 in, I got -1.8. When you put a value into the function, only one should come out. So that's why this vertical line test works. So again, if you look at this, we want want to look at, first of all, is it a function? And then two, I want to know what the domain is and what the range is, all right? So that's what we're going to be looking for. So first of all, if we draw the vertical line test, so imagine just drawing a bunch of vertical lines. It only crosses at one spot. Draw another vertical line. It only crosses at one spot. Draw another vertical line. It only crosses at one spot. So you can see it only crosses at one spot. So this is a function. So yes, it is a function. Now, the domain is the set of points on the x line. So again, if you, like at -4, see, it does exist. But at -5, and when x is -5, see, the function isn't here. Like, where is it? So it actually starts at -4. It actually, when x is -4, then the y value is up here. When x is -3.5, the y value is right here. When x is -3, the y value is here. So look at the x values, all of them, and you have to list them. So normally what we would do is list them, but you can't list an infinite amount of x values just separately. So what we're going to do is we're going to use interval notation. So the domain, again, on the x line, so literally look right here, it starts right there at -4. And notice it's at -4. When x is -4, it's a closed circle. So we're going to use a bracket. And again, if you keep following the x line, x line, x line, x line, x line, the farthest x line is at 2. So if you go slightly past 2, like 2.5, the function doesn't exist, right? If you go to 3, see, the function doesn't. The function actually stops right here, right here at 2. And that is a closed circle as well. Now, just to remind you, we did interval notation, but there is another way you could write this. So you could write it as x, the x value is in between those two numbers. So this is another acceptable way to write it, but interval notation is, both ways are accepted, but this is the way that we're going to be using is interval notation. All right, now let's look at the range value, because it does say give the domain and the range. The range is based off of the y's. So look on the y line, you want to go from the lowest value, just like we did here on the x line. We went from the lowest value to the highest value. So the range, we want to start at the lowest value, which is, again, the lowest value on the y is right here at -4. And then if you look at the highest value that it goes is +4. And notice both of those are closed circles. Remember, if it was an open circle, we would use parentheses. But both of these are closed circles. All right, so let's look at this. Give the domain and the range of these functions. So again, notice this function, for the domain, it starts at 1. Again, domain is x line. This is your domain. So it starts at 1. It's a closed circle. And notice it keeps going forever on the x line. Like, that's why you have an arrow here. So this literally keeps going on the x line. When x is 5, the function is here. When x is 6, the function is here. So the x values keep going on. So it keeps going on to infinity. And you always put parentheses on infinity, not brackets. All right, range, again, the low is, your lowest value on the y line is 2. You see right there, look at 2. And it's a closed, so we're going to use a bracket. And notice how high does it go? Well, it keeps going higher and higher and higher. So it goes all the way to infinity as well. So let's look at this next function, the domain. Again, the x line, notice it goes at, this is supposed to look at -2, right at -2. So it's a closed circle, and it's all the way to +2. The closed circles. The range, again, the lowest value on the y line, is at 0, and it's closed, and it goes all the way up to 3, and it's closed. All right, so again, just as a reminder, this says find the domain and the range of the function. So the domain, again, it just shows you, goes from left to right. The x line goes left to right. So the domain is from the farthest left that it goes So this would be right here, the farthest left would be -1. And then, so if I did the domain, this would be from -1, it's a closed circle. And again, the farthest right would go right here. It's at +4, and it's an open circle, so we use parentheses. And the range, again, tells you that it goes from the lowest to the highest, get on the y line. So it starts at -5 down on the y line, starts at -5, and it's a closed circle, and it goes up to +4, and it's a closed circle. So that's the range. Now, if I ask you to find f of 1, so again, this is the function f of x, and so f of 1 means if you look at 1, like literally look at 1, where is the function at? So at 1, the function is at 3. That's what we're looking for. So this is basically your x, this is your y. That's what we're looking for. So f of 2, if I did f of 2, it would be at 4. So again, at 2 is at 4. At 3, it's right here at 3. And f of 4, so go to f of 4. And again, notice right here at f of 4, the function is actually not defined because it's open circle. So that it is actually not a defined number right there because you have the point 0, 4, 0, but it's an open circle, so it has no y value actually at that. So you would literally just not put a value or say it's undefined at that point. All right, so now let's talk about graphing, finding the domain and range. So if I wanted to plug this in, this function, so any various functions, so you literally, I'm going to do the square root of x minus 2. And if I look at the graph, the whole graph starts at 2. So, I mean, you can follow the table if you want. And notice, let me change my table. So at 2, it's at 0, so 2, 0. Notice anything below that, or before that, I should say, like x is 1, it doesn't exist. You can't have 1 minus 2, and so you're going to have a negative value in there. So 2 is the first number you can have, and so at 3, it's at 1. At 4, 5, 6, it's at 2. And so you could scroll on here and just graph the nicer numbers, I guess. So at 11, it's at 3. So the function basically looks like this, and it keeps going slightly up like that. So now, again, find the domain and the range. The domain is, from your left to your right. So the domain is 2, starts at 2, and it goes all the way to infinity. And the range starts at 0, and it keeps going higher and higher to infinity. So that's your domain and range. Now, what if I graph the same function, but with only 2 to 6? So I only want to look at values 2 to 6. So if at 2, remember it was at 0, and at 3 it was 1, at 6 it was at 2. So we're only going to be concerned with that much domain, all the numbers in between, just between 2 and 6. So literally all the numbers, 2.1, 2.2, 2.3. So we're literally going to be talking about just the domain from there to there. So again, it's this same function, but I'm literally cutting it off from x is 2 to x is 6. So literally that function is what I'm graphing down here. So that's what I'm going to be looking for, is graphing a function with a restricted domain. So again, if I graphed another function, the same idea is here. So we have the square root of x, go outside of that, and we're going to minus 2. So again, the same thing, the function is going to look like that. And again, you can use the xy table to plot some points. At 4, 0, it's there. At 9, 1, it's here. So the function looks like this. All right. Now, how do I graph it just from 1 to 5? So, notice at 1, it's at -1, but it has an open circle, because that's what I have here, an open circle. And I want to go just to 5, so slightly higher than that. So it looks like that. Again, it's just this function just from here to here, just from there to there. And that's restricted domain, graphing functions with restricted domain.